Okay, so on the notes from yesterday, we got all the way through part one. Alright, so we just have to do D and E. So D is basically use the green sheet. So quick refresher here. It says find the probability that between 13% and 17% of these samples jog. Well, to write probability is P parentheses. We're finding that it's between, so it's going to be an inequality with a number on the left side, number on the right side, inequality in the middle. It's between what number and what number. And I can either write it as 0.13 or 13%, I don't care. And what am I estimating is between 13 and 17? In words? The what that jog? Percentage of the sample. So what is my symbol for sample or sample proportion? Alright, so refresher to back when we use green sheet. What's my first step? I'm z-score both, so z for 0.13. What numbers do I plug in? What's my z equals equation? Okay, so it's usually x minus u divided by sigma. Well, I don't have x right now, but this is our value. So what value am I plugging in? 0.13 minus the proportion mean, which is what? 0.15. That was in part A. Divided by the standard deviation that we already found, which is you're going to see the same thing over here for 0.17. How many decimals do I round to for z? 2. What do I get as my lower bound? Or what do I get when I plug in this one?
-2.
Well, this is 0.2 below, this is 0.2 above, so without typing anything in my calculator, this is going to be that direction. What's my next step? As a what? So I'm finding the probability that my z is now between negative 2.20 and 2.20. Then what? What do I need to do with these? So draw it and find the areas. And if it's been a while since you've done this, you might want to go back and look at this stuff because this is stuff that by this point I expect this whole part to take us about a minute. What is my, other than to look it up, what is my area for negative 2.20? What is,
No, never mind.
what is the other one? And what do I do with those? gives us 9722. So kind of pulling in to making the connection like the way that our homework was asked. Would it be reasonable for our sample proportion to be between 0.1 or 0.3 or between 13% and 17%? Yes, extremely reasonable. That's kind of probably what I would expect.
So when do you start considering?
We'll get into that more and more. Right now, you're just like very generally thinking, okay, there's a lot or there's not a lot. All right, so for part E, what sample size would be required to reduce the standard deviation of the sample proportion to 1/2 the value that you found in part A? I'm going to show you the long way before I do anything else. So our sample size in the problem is what? What's our sample size for this problem? So this is saying what sample size would be required. So we're going to change that to make the standard deviation of the sample 1/2 of what it originally was. You know with me of what it's asking. All right, so our original standard deviation was what? Supposed to be equals. I'll get my board. So if we're just thinking through this, we now want it to be what? So read the question. We want to do what to our sample size? Or to our standard deviation? Make it 1/2. So we want our new standard deviation now to be 0.004 what? Are you with me with my thought process so far? All right, so let's think about this. What's our equation for that? Square root of well, is it going to change the population parameter if I change my standard deviation? Or if I change, no. So we can go ahead and plug in what it was. What was our proportion? So 1 minus that's going to give us 0.85. So algebra here, I'm solving for n. So what's my next step? I need to get rid of the square root, which is square both sides. So that cancels out here. I take this squared. I'm not actually going to plug it in yet. I'm just going to write that I'm doing 0.00455 squared. So I don't have to type extra in my calculator. Algebra, what's my next step? So now I've got n times this equals 0.15 divided by, or 0.15 times 0.85. So to get n by itself, I type in what? I type that in. 6158. 50 what?
59.
And so what happens here is, what does it actually give you exactly?
6158.68.
We are talking about a sample size, right? And it's saying we need at least that many to meet our criteria. Even if this number was 6158.1, is 6,158 people enough? So you always have to go up to the next whole number because it's a person. We need that whole person. Now, this process that we just did is correct and it works. And there are years where that's the only thing I've taught. But let's think through this. This was our original N. This is our new N. How else can I get from there to there a little bit easier? And it might not be exact. Think about the change, how much it changed, it's about 4 times as much. If we want to reduce it by half, well, I guess reduce, multiply it by half, whatever you want to say it, then our N would be times 4. So to get 1 of standard deviation, we would always do N times what? How do I get, if this was a 2, that's a 4. And now we don't know if it's times 2 or it could be what? I'm telling you that it's squared. So we don't have to go through the math to do another one. So you can choose to do algebra, or you can choose to know this process. Nope. And so if I actually do 1540 times 4, what do you get? 62? 6160? Oh, yeah. What they're going to do is give you a problem like this on like AP exam, and one of the answers would be something like 6125, which isn't enough. And then the next answer would be something like 6175, and they'd say which is the lowest one that is enough, so that regardless of which process you chose, it's the first one that works. So the second part of this problem, or I think I split it as 2 different problems for us. If I want 1/3 of the standard deviation, and my N was 1540, my new N, how do I find that? Or what does that give us? Did I write that right? That one. So the part of the reason why I like to teach both is some people are going to get to the test or the quiz and be like, we haven't done that much. I don't remember what that thing is. But worst case scenario, I can go back and do algebra and figure it out. I thought that seemed kind of big.
But it's, the actual number is 13,860.
13,860. That's good. So any questions on this? So like I said, like on a test, it's going to probably give you different numbers and say what's the lowest one that works. And I don't care which way you choose to do it, the algebra way or this way.